Today we are presenting our project, the Transformer Kitchen. We started this project by studying the conventional kitchen, and we found an inherent problem in how most kitchens are designed based on the standard of the average able human profile, making it hard for someone who is handicapped to use it. Our project seeks to change that and reinterpret the kitchen as a part of one's life. A study on the history of kitchen evolution shows how the invention of appliances such as the stove transformed it into a special place to be in within a house. Through combining a newly developed appliances and robotic technologies, we aim to reinvent kitchen as a non-static object that can respond to its user. In tackling these new kitchen typologies, we started with a simple exercise, cooking.
The example recipe is potato bake, which involves washing, peeling, and slicing potatoes and baking it with a cheese sauce. This is images extracted from the video of us cooking. It includes us preparing, chopping the ingredients, preparing the cheese sauce, and layering the potato in the sauce, then baking it. We found that to make this recipe, the oven, stove, and fridge needed to be in close proximity for the robot to function, giving the idea of an all-in-one kitchen bench unit.
To further understand which processes could be performed by the robot and which are done by the human, and to understand how to reinvent the kitchen, we diagrammed and analyzed the process of cooking the potato bake.
We have looked into multi-robotic kitchen as a precedent study, where it uses a combination of sensors and optical cameras to map the ingredients, cookware, and utensil within the kitchen. It can cook from scratch and cleans up afterwards, and the user can also choose from over 5,000 recipes. We've also studied disabled kitchen design, where the benchtop height is at around 750 millimeters table height, and there is space underneath the benchtop to allow for the wheelchair.
Modern kitchen technology and appliances such as tabletop vents, lower door handles for the fridge, sliding storage spaces, and adjustable kitchen bench has made it more accessible to a disabled person. To facilitate the robot arm's movement and for it to perform tasks efficiently, we investigated existing multifunctional tools and looked at how we can reinvent certain tools to better fit the robot. We then looked at the qualities to make a sculptural kitchen. Is it the color, the form, or the material? From the precedents, we extracted guidelines that we incorporated into our design. We focused mainly on the ergonomics and systems that would benefit a handicapped person in the kitchen. Here we have our proposal of the Transformer Kitchen, ergonomically designed to a person in a wheelchair and equipped with a robot arm to collaborate with the human. To properly design a flexible kitchen for the handicapped robot and average person, the ergonomics has to be studied to identify areas of collision, collaboration, and restriction. The diagram illustrates the different zones existing in the conventional kitchen on the left, followed by the Transformer Kitchen redesigned by us. Built-in appliances and allocated work zones ensure better maneuvering, reducing obstruction.
We came up with two versions of the kitchen, named Model V1 and V2. The V2 model has two robotic arms installed to be able to help with more tasks. The bulkhead or machine compartment in the ceiling is bigger. The idea is that someone doesn't have to invest in the full-blown two robotic arms and can opt for the one-arm V1 model and upgrade in the long run if needed. We are looking at the V1 floor plan now, where kitchen design utilizes a reconfiguration of a kitchen island with appliances installed as a recessed element located in specific spots to be reached by the robotic arms, but at the same time allows a person to work independently on different tasks without colliding with each other. And in some cases, still allowing for some collaboration to be done between the two. We're gonna look at the V2 kitchen on the next slide, bigger bulkhead. And then we're gonna look at the short section, which starts to show how the kitchen operates as a non-static object, whereas pointed out by number 2, the benchtop height can adjust to the user's profile, and robotic arms hung from the ceiling space with its own mechanical robotic zone to support its movement. The long section in the next slide shows how the recessed appliances works, in this case showing the oven, as well as the sink. On the next slide, we're gonna look at some diagrams showcasing the human-robot interaction happening in both models, in this case, the V1 model, with someone who is able. If we skim through the next diagrams, we'll start to see the process for cooking a potato bake, where the robot's doing its own thing and the human's doing something else independently, and at last working collaboratively. Here's another version where it's the V2 option with someone on a wheelchair. And we will skim through the other diagrams as well.
This is a 3D printing simulation to show that several attachment tools can be customized on the 3D printing bed and stored above on the tool compartment for future use. The robot tools were designed for the robot to be able to perform the most common tasks in the kitchen, such as washing, peeling, cutting, and grabbing. They utilize a rotatable joint for it to be easily swapped, adjusted, and stored.
This is our V1 version, which has a single robot arm and a single toolbox. It plugs into the toolbox above to take out a brush tool, which washes the potatoes at low speed and peels them at high speed. The other limb of the arm then slices the potato by rotation. Here is the arm picking up additional potatoes with the claw tool from the pot to be sliced. In the two-arm version, there are two toolboxes, and the arms can travel along a track with motion sensors to prevent them from colliding. The arms are able to rotate to alternate between tools. It lets the human try the cheese sauce so he can check if it needs any seasoning. The dual function tools are also able to rotate, in this case, to slice the potatoes. The arms work as a fully functioning body, being the extra arms of the human and working together to pass items to each other and to the human. I will now show the movie. In contrast to the V1 version, the V2 has an additional arm, a wider bulkhead, and two toolboxes on either side in which the arms click into. The cooking cycle can be activated by the interactive screen shown in black. In this case, both robots work together to make the potato bake whilst the human spectates. One arm slices the potato whilst the other makes a cheese sauce. The human is able to taste the cheese sauce to see if it needs any additional seasoning. There is a removable container in the center so that any dirty tools can be dropped in there. After the cooking cycle is completed, the arm closes to the sink and do all the washing, and the robotic arms will return the tools to the bulkhead above. Acting as an extension of the human, the robot arm learns behavioral sequences of the human. He knows the human likes to snack on ingredients whilst the robot cooks and passes the shredded cheese to him.
Our V1 design featured one robotic arm with one toolbox in the bulkhead. The bulkhead is smaller compared to V2 and aligned with the kitchen island's width. The V2 design consists of two robotic arms and each has its own toolbox at the bulkhead. The robot 2 storage is at the ceiling space and the human storage is concealed within the kitchen island. The bulkhead of V2 is extended longer to allow space for the two robotic arms. A concealed recessed 3D printer is in the ceiling zone where it can 3D print different tools for the robotic arm. For the appliances and equipment, they are integrated into the kitchen island. The materials for the kitchen island and the bulkhead consist of the options of high-pressure laminates or Phoenix self-healing laminates. Both can be applied in the horizontal and vertical surfaces, and it is durable with good heat and scratch resistant, and it is easy to clean. To further enhance the kitchen's sculptural qualities and to incorporate a hint of individuality, the color is fully customizable. To sum up, our vision for the kitchen is an object instead of a room. It is a statement, like a sculpture or a piano, something that makes the room alive. The Transformer Kitchen is inclusive, adaptive, and it is equal. Everyone should be able to access it, and by everyone, this includes different types of people with different body conditions. Attached on the appendix includes our daily studies and collaborations on the design development for the Transformer Kitchen. Thank you.